Hey everyone, welcome to Coding Simplified, and today we'll see about the quicksort. So quicksort is one of the best sorting algorithms. So today we'll see all about the quicksort, like what's the logic to sort the algorithms using quicksort, then what should be the time complexity, and like what's the code so that we can sort the given array. So like if you see in this case, we have this array and this is in any random order, and now after sorting it should be in this manner. Now like it's shown us that we can have the descending manner as well, but so it's just that you need to change little bit conditions and then you can do as per your requirement. So today we'll basically see that how we can basically sort using quicksort in ascending manner, right? So if you see in ascending manner, it should be all the values are in sorted manner and all the values are in ascending manner, right? Now let's see about the quicksort. So quicksort says the concept of quicksort is, let me write the values here again. Here I have 8, 36, 15, 2, 1 and 18. So it says that let's focus on this element, right? And then your aim is to put this value at its correct location, right? And once you put all these values to correct location, so what will happen? Let's say if let's select this one, this is the point where you will put it if it is the correct location, right? So once you put this value at its correct location, then all these elements which are smaller than this one, this will be on this side, right? So this can be in any order, but for now your main aim is to put this one. So now it can be like 8, 6, 2, 1 here. So all the lower element will be on this side and all the bigger element will be on that side. So again we can have in any order 8, 18, 13, then where we have 15, right? So now you see that this 12 is in its correct location, right? So once you put this 12 into its correct location, then what I will do, then it means the location of its correct position. Now I need to sort this thing, this one, and then similarly you need to sort this one, right? So now what I will do, that recursively I will again process this one, and again I will do the same thing, that you need to put the 8 at its correct location. Similarly you need to put this 18 at its correct location. So what will happen, that once you will put 8 at its correct location, then it will be something like this, because 8 is the largest element, so it will be here, and then we can have the all other elements here. So now let's say this is in here, we have 1, 6 and 2, right? Now what will happen, that you have this element and your 8 is at correct location. So now if you see, my 8 is at correct location, 12 is also at correct location, and similarly here 18 will also be at correct location, because we'll do recursively. So you know what is happening, first of all we solve this one, right? We put this 12 at its correct location. So that code will see that how we'll put this 12 at its correct location, but first understand the concept, that how quicksort is happening. So my aim is to put 12 at its correct location. So when I put 12 at its correct location, then all the elements will be at lower side and all the greater element will be at another side. Now what will happen, I will again recursively call the same thing on this part. Now again my aim is that you need to put this 8 at its correct location. Now the same concept is here, you need to put this 18 at its correct location. So when I will put this 18 at its correct location, so all the lower element will be at this side and all the greater element will be at this side, right? So now if you see that when I put this here, now here I have only one element. So again I'll process it further and I'll process it further. Now because it has only one element, so it won't process further and it will be as it is. Similarly for 30 it will be as it is. For 8, because it has also one element, it will be as it is, right? Now for the 162, so again for 162 my aim is to put this 1 at its correct location, because this is the first point. So I say this point, this is basically a pivot point. I say that my total aim is to put this pivot point at its correct location, and when I will do this process, that to put its correct location, then all these value, all the lower values will be on the left side and all the greater values will be on the right side. So what will happen, now it after this one, now it will put this 1 at its correct location, and now it will send this 6 and 2. Then my next time will be to put this 6 at its correct location, and when the 6 will put it correct location, then it will be 6 here, 2 here and 1 here, right? And all the elements are as it is. So now it will be 8, 12, which I am copying from above, 15, 18, 30. So if you see that here my all the elements, all the row, all the array elements are in order, right? So now what we did here, if you see, this was my first step, right? This was my first step, that I put this point into its correct location. Then this was my second point, that I parallelly, because this is already in correct location. Now I basically parse this part, that again do the same thing which I did here on this part and on this part. Now this thing is happening in parallel. Now again, though they are doing the same thing, but they are doing in parallel. Again it will process it further, and again then it will do this one and this one, because here we had already done this one, because this was one element, right? Now after that again it process, and then it process. So for each step we are basically sorting the point, to pivot point to its correct location. And whenever we are sorting, then we are putting all these value into in correct manner, right? So if you see, so here that we have understood that like how we'll do it. Now the main point is how you will put this 12 at its correct location, right? And then how all the left point, all the lower point will be at its left, and how the greater point all its right. So now let's see that thing. So here, let me write it again. Here I have 12, 8, 30, 6, 15, 2, 1 and 18. Now my point is that I need to put this 12 at its correct location, right? It means the all the lower point will be on the left side, then 2 to 12, and all the greater point will at the right side, right? So what I'll do, I'll basically take two variables. One will be I and one will be j. Now I will be starting from here, from the pivot point, and the j will be starting from at here, from the last index, right? Now I will check that as soon as I find any greater element from the 12, right? As soon as I find that any greater element from the 12, then it means that will be in this side, because if there is any element which will be greater than 12, it means that will be this side. So at the starting, what is happening? My 30 is somewhere here. Now it will be basically the position of this 30, if you see here, because 8 is lower than this one, right? So if 8 is lower than this one, it means the position of 8 will be somewhere here after this 12. So it means I will not do anything if the element is lower than this one, right? So now first of all I will check this 12. Now 12 is not greater than, so it means this will be as it is. Now I will go further. Now 8 is again lower than 12. It means, because this is my pivot point, you need to understand that I want to put this point at its correct location, right? So this is my pivot point. Now I will check the value at I is lower than the value at pivot. It means again it will be on this side, right? Now again it means I need not to do anything. Now if you go further, now 30. So I know that 30 is basically greater than 12. So if 30 is greater than 12, it means it will be somewhere here basically, right? So I stop here and then I check from the back. Similarly for the back, what I do, if the element we are checking is greater than the 12, it means obviously it will be on this side, so I won't do anything. But if the element which I am checking is lower than 12, it means I need to basically put on this side, right? So what I do, like 18 is greater than 12, it means I need not to do anything. But 1 is smaller than 12, it means the position of 1 is not here, it will be basically swapped, it will basically this side, on the left side. So what I do, now my j is here, right? So if you see, my I is at this place. Let me write here indexes 0 1 2 3 4 5 6 7. So my I is at second index here and my j is here. Now if you see, this is the greater element than 12 and this is smaller element. Now the ideally we should basically swap the element, because this is a smaller and this is a greater. So whenever we are stopped, it means now I will swap these two elements, this one and this one, right? Because the bigger element should be on this side and the lower element on this side. So what I will do, I will swap the element. So after swapping, what it will happen, this will be 30 will be swapped by 1 and this will be 6 15 2 and here I will have 30 and 18, right? And now my I is at my I is at here and my j is at here. Now what I will do, again I will do the same thing. My pivot point is still same. Now I will check 6. Now I will check 1. So 1 is smaller than 12, right? Now I'll go further. Again 6 is also smaller than 12. It means it will be on this side, so I won't do anything. So you need to basically understand this point, that why we are doing, if the element is lesser than the pivot point, it means it will be on this side itself, so it means we need not to do anything. But if element is greater than 12, it means it will be on this side, so there we stop and then we are swapping the element, right? So now here again the 6 is smaller than 12, then we are fine, so again we increase the I. Now 15 is greater than 12, it means this should be on this side, this should be on the right side, so we stop here. Now we check for the j. So now here 30 is greater than 12, it means we are okay, fine. So I decrease the j and my j will be here. Now 2 is basically less than 12, it means the 2 should be, ideal position of 2 is this side. So what I do, I basically swap the I and j position. So now the value of here and value of here will be swapped. So after swapping, what will happen? Here it will be 12, 8, 1, 6, 2, 15, 30 and 18. Now my basically after swapping, what will happen? My j is here and my I is here, right? Now because 2 is less than 12, it means again it is fine, so I'll increase the I, so my I will be here. Now 15 is greater than 12, it means I stop here, right? Because 15 is greater than this one. Now j, 15 is greater than 12, it means we are fine. Now I decrease the j, so my j will be here. And now you see here, now the value here is less than this element, it means I stop here, right? So I stop for the j as soon as the value is lesser than the pivot point, right? Now it means, now what is happening, the I is not less than j. Now I is basically, I has basically passed the j, and whenever we have this condition, so basically we check that until I is less than j, it means we are fine, we can basically swap the element. But as soon as this condition not matches, like this case, as soon as condition is not matches, in this case, then we'll stop here. Now what we'll do, now basically the j position, now I will swap the pivot point, I will swap the pivot point position to this one, and 2 will be here. So what will happen, this 2 will be on this side, 2, 8, 1, 6, and then 12 will be here, 12, 15, 30 and 18, right? So if you see here, now this is the case, when as soon as my I is greater than or equals to j, then I stop here and then I swap the pivot point. So now if you see, the position of 12 is exactly correct, right? All the elements which are greater than 12 are on the right side, if you see here, and all the elements which are lesser than this one, these are on left side, right? So once I put the position, once I have put 12 here, then again the same thing I will iterate on this one. Earlier my start and end was, my start was at 0 and my end was at here. Now my start and end will change. So my, for this case, my start will be start and my end will be, j minus 1, because for j I have already placed, so j minus 1 means this one. And for this case what I will do, it will basically go from j plus 1 to end, because my j is basically this one, right? So it means j plus 1 to end, then it means iterate the same thing from start to j minus 1 and iterate the same thing from j plus 1 to end. Now you will do the same thing again, and after completing all this thing, then your array will be fully sorted, right? So now let me show you the code so that you can get it better how we are doing. So here is just that we are writing, here is my array, and this is just that I have write all the functions, all the values, and here I'm calling the quicksort. So in quicksort I'm passing the array, I'm passing the starting index 0, and I'm passing the end index, which is array.length minus 1, and I'm calling the quicksort. So here I am taking a pivot point, so pivot point will basically initialize to the start variable, right? And then we have j and we have I and we have temp, right? So basically I can write it some like this so that it will be better. So now I have I, j, so I basically will initialize to start always and j will initialize to end, right? And the temp is basically to swap the element. So now what is happening, that you will basically iterate this until start is less than end, right? You will basically initialize all the variable, you will initialize pivot, I and end. Now while I is less than j, what you do, that until your element of array of I is less than the array of pivot, it means you can go further. So in this case you go I plus plus, right? And you need to check this condition as well, that your I should less than end, right? That it should not, that it should have reached the till the end. Now you can go I for I plus plus. Similarly, what you can do now for here also, your a of j, now we are starting from the back. So as soon as your array of j is greater than pivot, then again you can decrease the j, right? And again similarly we can put a condition here that j should be greater than equals to 0, right? Now what happens that as soon as your value is greater than pivot point, then you keep on decreasing the j. Now what happens that whenever there is mismatch, now at this moment if I is less than j, it means I need to swap the element, right? That's what we did, we swapped the element. Now after swapping the element, we again check that again if your I is less than j, it means again I can go further and I can swap the element, right? So if you observe here, what we did that first of all we basically swapped the 30 with the 1. So after the swapping, after swapping this 30 and after swapping this 1, then my 1 was here and my 30 was here. So it means my I was here and my j was here. Then again I checked because my I was less than j, so I checked again I need to go further. So then I swapped this 15 and 2, right? So then I swapped this 2 and 15, and because after that when I went further, then my I was greater than j, so that is why at that moment I stopped, right? So the same thing we are doing here, that's why we have put this I less than j condition in the while loop, that as far as your I is less than j, you will keep on doing the work, and after that once your I is greater than or equals to j, at this moment you need to swap the pivot point, right? So that's what we did here, that after j was greater than I, after I was greater than j, then we swapped this pivot point, then we swapped this 12, with the jth position, right? So that's what we are doing, that swap this point, and this is how we swap, that we basically initialize the temp, the value at the pivot point to temp, and then we do this array pivot equal to array j and array j equals to temp, right? So this is basically, through this we can swap the element. So now once you have done the swapping of the pivot point, it means your one step is done, right? So this is the thing is happening, this is the point in one step, that in one step we are doing all these thing, and once you are done this all this thing, then what you are doing, then you are again calling the quicksort function for the start and j minus 1, and then for the j plus 1 end, right? And that's it, and then it keep on working, and at the last all the arrays will be in the sorted manner, right? So what is happening, that once you are done with this one, then you are again calling the function quicksort from start to j minus 1 and j plus 1 to end, right? So this is how we are solving the quicksort function. Now if you see the time complexity, so if you see here that we basically divided, once we have calculated this one, then we are divided into two parts, that this is one part and this is another part, right? Then again when we calculate this one, then again we are dividing into this one. So how many steps are there, right? If you see that we are always doing in binary part, means for me we have basically two parallel recursions, right? So it means if we have an element, then these will be total log n steps, these will be log n steps, right? Because we are doing in parallel in two recursion. So first we divide into two part, then again we divide into two part, then again we divide into two part, so it will be log n steps, from here to here it will be log n step. Now what we are doing in each step, we are basically comparing the item, because when it was the first, then we compared all the items from I to j, right? We compared all the items from I to j. When we were in this step, first of all we basically covered these items, then also in parallel we also covered this item, right? So it means here also we are checking n items. Then when we are going into this one, again here we are checking n items, because you see here that we first of all check this one, then we check this one, then we check this one, then we are checking this one. So it means for each step we are comparing n items, right? So my time complexity will be, for each step I am comparing n items, and how many steps I have, log n. So my time complexity will be n log n, right? And if you see the space complexity, so in this I am not using any extra space, so my space complexity will be big of 1. Now let's say if our input is in ordered manner, something like this, let's say we have 1 2 then 5 then 6 then 10 then 15, And if I need to apply the merge sort here, so what will happen that if I do using this one, using quicksort, so my aim is that I want to put this value into its correct location. So after putting the value its correct location, it will be here itself, right? Then I will iterate the loop on this one. Then again I'll do the same thing, that put this value into correct location, then I'll putting here, then I'll again call the function here. Similarly, it will put 6 here, then it will again call the function, then it will put the 10, and then it will put the 15. So if you see here that how many steps are happening, if there are the 5 elements, then the steps are happening is exactly n minus 1, right? So overall means if they are in particular order, that basically there are happening big of n steps, right? So it means the quicksort is not very good if it is already in a ordered manner. Ordered manner means it can be in descending manner, it can be in ascending manner. So if someone asks you that if our input is in some ascending manner or already sorted, so whether quicksort will be good. So in this case your quicksort will not be good, because in this case your time complexity will be big of n square. Because how many steps it is happening, you have n steps, and then how many steps are n step, and in each steps you are comparing n, so it will be overall big of n square, right? So if it is already in a ordered manner, then in this case the merge sort is better, because in merge sort it doesn't matter whatever the input is, it will always take the nlog n, right? So if someone asks you that if we have in ordered manner, then I would choose the merge sort, right? If it is in random manner, then quicksort is very good. Quicksort is even better than the merge sort, right? So that's all guys about the quicksort, and if you have any doubts, then please write in the comment section and I will try to explain that. And I will also put the source code into description section, so if you want, then you can also get it from there. So that's it, and if you have liked the video, then please like it and subscribe to the channel for more such videos. Thank you.